So once you've thought about your data more, you may want to get a bit fancier with your analyses. So let's go to Analyze and Fit Model and have a look at some other things that you could do. So you might be interested in the relationship between length and weight to continuous variables. But you might think that that relationship might differ between the controls and experimentals for some reason. For instance, you might think that you'd expect to see a nice positive relationship in the controls, but perhaps in the experimental group you think that that might mess up that relationship somehow. Now there are more advanced ways to test that, but very simply, you could just do the analysis separately for controls and then do it separately for the experimental group. So to do that, that's referred to doing an analysis by treatment. So that's what that by means here. So I can look at the relationship between length and weight and do it by treatment. Okay, so we've got the same analysis that we saw before when we looked at two continuous variables, but now it's presenting us the results separately for the control group, right? So we can go down here and it gives us the regression statistics just for the control group. And we see there's a massively significant effect, so we can reject the null hypothesis that there's no relationship between the two variables. We can hide that so we don't get confused, and now just look at the results for the experimental group. And so again, we get the slope and the intercept. And the results of the effect tests, right? So again, significant. And now this is just for the experimental group. And you can also get a hint that you've done the analysis right and you've just looked at one group at a time because it tells you your sample size here. The number of observations is 11, whereas the total number of observations is 22. Another fancy analysis that you might want to do, again, we'll go to Fit Model. You might want to ask whether weight differs between treatments, but also you think weight might differ between individuals with good outcomes and bad outcomes. And so you can look at the effects of both treatment and outcome on weight at the same time. This is called a two-way Anova. And so let's see what that looks like. So here it's given us the means for the control group and the experimental group, the mean for bad outcomes and for good outcomes. And then if we scroll down, we can get the results for the effect tests. So for the effect of treatment, there's the p-value's much higher than 0.05, so there's no significant effect of treatment. And the effect of outcome is the p-value's above 0.05, so again, it's not significant. We can't reject the null hypothesis that there's no effect of outcome. So what these numbers are telling us are that even adjusting for potential differences in treatments, there's no effective outcome. Or we could also say things the other way, that even adjusting for differences in outcome, there's no effect of treatment. Now you might notice that this is 0.07, so it's kind of close to 0.05. It's almost significant. And that's true, and that's something you might want to consider when interpreting your results, that maybe there actually was a significant effect that you weren't able to detect. Well, maybe there wasn't a biologically real effect that you weren't able to detect because perhaps your sample sizes were too small. Now, in this case, I used random numbers, and the way I generated the random numbers, there should not have been a difference between outcomes. So this goes to show that, sometimes you'll get a result that looks kind of significant, completely due to chance. And that's definitely what happened here. These are just random numbers, so there's no real difference in outcome in these numbers.